Hello, I hope you're doing well. It's the Easter break, and I know lots of students are revising for their GCSEs. I thought to create a series of topic past paper questions in preparation for the OCR Additional Maths exam. But actually, these videos apply to all exam boards and to GCSE maths students and equivalents. This is the first video of the series and it's all about differentiation. So, the first question. Find the equation of the normal to the curve y equals x cubed minus 2x squared plus 2x plus 4 at the point 2, 8. The important bit here is the normal. Not the tangent, the normal. So first I'm going to differentiate to find the gradient. So dy by dx is, remember when you differentiate, you look at the power, multiply that by the coefficient of the x term, and then subtract 1 from the power. I'll go over the first principles of differentiation in another video, but that's the basic kind of way to differentiate. So you're going to get 3x squared minus 4x plus 2. Remember, the 4, when you differentiate it, you get nothing. There is no x term there. And we want the gradient specifically at the point 2, 8. So I'm going to sub this in to our gradient. So at this particular coordinate, our dy by dx is going to be 3 lots of 2 squared minus 4 lots of 2 plus 2, and that will equal 4 times by 3, which is 12 minus 8 plus 2, which is 6. Now, we want the equation of the normal. So that's the gradient of the tangent to the curve. For the normal, if you find the reciprocal of the gradient, so we do 1 over the gradient, and we stick a negative sign in front of it. So our normal gradient will equal minus a sixth. We know that 2, 8 lies on this normal because it lies on the curve. So we can sub this point in to find our equation of the normal. So we have y minus y1, so y minus 8 equals m, which is our minus a sixth, into x minus x1. x1 is 2. And we rearrange to get 6y equals 50 minus x. And then from here, we can divide through by 6. So we get y equals 50 over 6 minus a sixth x, where our gradient is minus a sixth and the y-intercept is 50 over 6. Okay, on to the next question. This is taken from the 2018 past paper. And there are 2 parts. So we need to find the coordinates of the points where the line cuts the curve. So, the line cuts the curve. What does that mean? That means there's a point of intersection here. Cuts means intersects. So let's use this bit of information and equate the 2 graphs. So you get 7x minus 9 equals x squared plus 2x minus 5. Hopefully you can see where this is going. We'll get a quadratic and we'll need to solve it. So I'm going to move everything to the right hand side to get x squared minus 5x plus 4. and that equals 0. Now we can factorise this and find the roots. So we get 2 linear factors, x minus 4 and x minus 1. Because minus 4 times minus 1 equals 4, and minus 4 plus minus 1 equals minus 5. Okay, and let's set each bracket equal to 0. So we get x equals 4, and x minus 1 equals 0, therefore x equals 1. So let's find the coordinates of each point of intersection. So I'm going to sub our x values into the line, I think. I think that's going to be easier. So we'll have y equals 7 lots of 4 minus 9, which will give us 19. And here we'll get 7 lots of 1 minus 9 to give us negative 2. So to summarise, our points of intersection are 4, 19 and 1, minus 2. Hopefully that makes sense. Let's look at the second part. Determine whether the line is a normal to the curve at either of the points of intersection. So I'm going to find the gradient of the curve. You guessed it, we need to use differentiation. So part 2. Let's find dy by dx. You can also write f dash x, but I prefer using this notation. So you have 2x plus 2. Now, let's substitute these points into our gradient to get let's do 419 first. What do we get? We get dy by dx equals 2 lots of 4 plus 2, which is 10. And at 1, negative 2, what do we get? Dy by dx equals 2 lots of 1 plus 2, which gives us 4. We need to look at the normal. Okay, so what do we have to do? We need to negative reciprocate each gradient. So we'll get, for this one, maybe I'll put, this is A, this is B. So for A, our normal gradient is going to be negative 10. And for B, our normal gradient will be negative 1/4. Now we're checking whether the line is a normal to the curve. So now we need to look at the gradient of the line. It's in y equals mx plus c form, so our gradient is simply 7. Now this does not match up with minus 1/10 or minus 1/4. Therefore, the line isn't a normal to the curve at either of the points of intersection. Okay, next question. Find the equation of the tangent to the curve y equals x squared minus 3x at the point 4, 4. I think you know what's going to happen. We're going to differentiate the curve. Now this is slightly interesting because it's finding the equation of the tangent. So far we've found the normals to the curve. This time it's simply the tangent. So you have 2x minus 3, and we're simply going to substitute the point in. So at 4, 4, our gradient will be 2 lots of 4 minus 3, that's 5. So we need the equation, so I'm going to write y minus y1, which is 4, equals our gradient m, which is 5, into x minus x1, which is also 4. Rearrange that to get y equals 5x minus 16. That's it. Slightly longer question here, and there are 2 parts. I can see some key words in here that I'm going to highlight. So, we have a curve's equation. Points P and Q lie on the curve. And we have the coordinates of point P. And you need to find the equation of the tangent to the curve at the point P. So remember, the equation of the tangent to the curve. In the exam, I would recommend just underlining those key bits of information. Part I, we're going to differentiate the curve. So x cubed will give us 3x squared minus 6x minus 3. The coordinates of P are 3, minus 5. So at P, dy by dx is going to equal 3 lots of 3 squared minus 6 lots of 3 minus 3, which gives us a grand total of 6. And here we need to find the equation of the tangent. So I'm going to use y minus y1. y1 is negative 5, so it's going to be a plus 5, equals our gradient 6 into x minus 3. Rearrange this to get y equals 6x minus 23. And that's it. The tangent to the curve at Q is parallel to the tangent to the curve at P. Find the coordinates of Q. Okay, tangent, parallel, tangent. Key bits here. So, we know that our gradient, dy by dx, which is 3x squared minus 6x minus 3, is equal to 6. That's the gradient of the point P, specifically. So I'm going to solve this. So we'll get 3x squared minus 6x minus 9 equals 0. Make our lives easier for ourselves. Let's divide by 3 to get x squared minus 2x minus 3 equals 0. Now we can easily factorise this, can't we? We get 2 linear factors. We have an x minus 3 and an x plus 1. Set each bracket to 0, so we get x minus 3 equals 0, therefore x equals 3. X plus 1 equals 0, therefore x equals negative 1. So let's look back at the question. What was it actually asking us? Find the coordinates of Q. Okay, so this is interesting because the coordinates of P, are 3, minus 5. So actually, we're going to ignore this value. This is actually point P. We can prove this by finding the y coordinate. So we're going to focus upon the second value of x. So we need to find our y coordinate here. So we have y equals, now we know that point Q lies on the curve, and we have our curve's equation, so we can simply substitute our value of -1 in here. So we're going to get a -1 cubed minus 3 lots of -1 squared minus 3 lots of -1 plus 4. And if you do that, you will get y equals 3. So our point Q is going to be -1, 3. Now I think the important bit here in this part is the parallel to the tangent bit. So when two lines are parallel, they have equal gradient, which is why I equated our gradient function to 6. Because we know that the gradient of the tangent at P is equal to 6. So we can just simply equate them and solve to find our x and y values. Okay, so our last question on differentiation is all about kinematics. So by now, you might have asked yourself, what's the point of differentiation? Yes, I can find the gradient, but what's the point? Let me tell you. There are loads of real-life applications of differentiation. One of them is applications to kinematics. So engineers can find the velocities and accelerations of moving objects. To do that, you need differentiation. So let's get on with this question then. A train accelerates from rest from a point O such that at t seconds, the displacement s meters from O is given by this formula. Show by calculus that the acceleration is constant. Okay, so I'll talk through a little bit of theory for this question. So if you think about a displacement time graph, when you find the gradient, you're really finding the velocity. Think about a velocity time graph now. When you find the gradient, you're finding the acceleration. Now, in this question, we're given the displacement. And we need to find out the acceleration and prove that it's constant. So how do we get from displacement to acceleration? Well, let's think about it. So we have displacement, velocity, and acceleration. So I told you to get from displacement to velocity, we need to differentiate. To get from velocity to acceleration, we need to differentiate again. So we're going to have to find our second derivative. So let's take one step at a time. So let's work on part I. We have our displacement, and let's differentiate that to get velocity. So velocity is ds by dt, which is 3t minus 2. Okay, that's our velocity. To find our acceleration, that's dv by dt. We differentiate our velocity with respect to time, which gives us 3. Therefore, our acceleration is constant. It doesn't depend on our time. There is no t variable here. It's just a number. Therefore, it's constant. Okay. Part II. Find the velocity after 5 seconds. So remember, we already calculated our equation for velocity. That's 3t minus 2. And we want it after 5 seconds, so we're going to substitute t equals 5. And at t equals 5, our velocity is 3 lots of 5 minus 2, which gives us 13. I'm going to put our units in. That's going to be meters per second. And that's meters per second squared. And that is it. Hopefully you found the first video of the series useful and enjoyable. If you did, please consider leaving a like and subscribing to my channel. I hope to see you in the next video. Thank you for watching, and bye bye.